All right, everyone. Good afternoon, and thanks for joining. We will have our first Friday of the month webinar on the second Friday of October as to some setting issues during the course of a week ago. Thanks for your patience and thanks for joining. We will use YouTube from now on simply because the recordings can be shared easier and like this those that could not attend during the Friday will be able to look at the recordings at a later stage. Let's see if we're going to cut those into chapters and make it accessible through our partner portal as well. And like this, we would have our little video clips per topic easier to find and easier to do a rehearsal on different topics once needed. Today's focus will be on the solution overviews. So therefore, whoever is new to Magos live now or at a later stage, welcome and thanks for your interest. Quick overview. What Magos does is what will follow, and then a couple of examples. Before I start with that, I almost forgot again. A little one from last webinar in September. I got a capture for you to highlight the classified vehicle. So therefore, that was the recordings. Here it comes up again as classified. That was the recordings I did after the webinar last time. It did not 100% work as to the Ethernet connectivity from the demo kit to the display, but never mind. That is just a closing an open issue of showing that the vehicle was actually classified, and the rest was only due to connectivity, as I just said. So therefore, we start with the solution overview. Again, thanks for everyone who's new to Magos, and the idea is to give you a little bit of an overview who we are, what we do. As most of you know, Magos is an Israeli company that started quite some time ago after careers working with radars in the military environment. The perception has been and is that radars are the best detection technology as such for the outdoors, meaning therefore as well for perimeter security purposes. However, obviously, military grade technology can be very, very costly, much bigger, and as well way more complex, or maybe not paying as much attention to the user interface. So therefore, the idea has been to shrink that down to something that is applicable for the security market, and that's what's been done in the initial and actually ongoing development cycles of Magos. So therefore, we have a very small box now, and nevertheless, the uh, sophisticated experience of radar professionals is obviously built into the system. We started international sales only from 15-ish onwards, where basically the first international projects have been started. Reason for the delays as well, down to the fact that we delisted, or it was a process to get the product delisted, and therefore nowadays we can export without export control such a device for security purposes worldwide, as well across all verticals. Of course, ultimately, whether or not a radar needs to be licensed is at the end national decision. We use a frequency in the C band that is in most areas of the world, including EU, is license free, so therefore Magos can be imported and used in such perimeter projects without any communication with the national authorities in that purpose. Nowadays, we have installations all across the world. I think in more than 40 countries by now, as well. Literally in every country in Europe, we have an installation or more, and hence it's not really a startup situation, so to speak. And still, we are relatively new to many. What is it we bring to the table? The radars as such is a hardware that is of up to about 3 to 3.5 kilograms, so very easy to handle. The radars do not have any moving parts, so therefore as well from the view of maintenance, it's very robust. And you don't have much more than the interface for the screws of the bracket. So therefore, as well, with regards to the installation, it is very doable. Obviously, during the design, something that has always been in focus to ensure that the installer can handle the mounting of the radar without big hassle. Radars come with the relevant certification, obviously, that includes CE, FCC, and others with regards to the local versions of the product. And that summarizes probably the hardware. We will look at the distances that we offer on a separate page. The second part up to the right here is the software part. On the one hand, we have our MAS user interface, which allows the typical setup of radar CCTV integrated solutions on a map, and the handling of the different sensors and the different areas and all the relevant settings. On the other hand, we brought or launched in the market back in 2019, I think it was, the MAS AI application, which is a video-based analytics of the video stream to be able to categorize the different objects once detected by the radar. So therefore, we can distinguish between a person and a vehicle, but as well wildlife, and we're going to look at that in a second. Last but not least, this is in almost all of the cases an integrated solution, as we mentioned with video, but as well with the C4Is, VMSs of that world, and hence the third part is always the integration to third party, and in general that includes the PTZ manufacturers, where we are integrated with probably pretty much everything that is typically used in these markets. And if there's a new model, then we will create a software model for our purpose and make sure that the steering of the camera and therefore the auto follow provided by Magos will work with the camera your customer uses. Second, the integration with VMS and software worlds, as we said. So therefore, there is a defined way of an API in most of the cases nowadays, where the integration is done relatively lean, and therefore you can assume that we are integrated with the typical VMSs, let's say, of that world. But if there's a new one, it can be delivered. So therefore, third-party integration here, hardware and software. Now, how does it look?
For ultimate perimeter protection, you want a comprehensive solution that is smart, effective, and easy to integrate. Magos' end-to-end solution combines the very best of all worlds. Advanced ground-based radars, easy-to-use area surveillance software, and smart AI-based target classification. With high resolution, high coverage, and detection ranges from 150 meters to 1,000 meters. Our radars offer the best performance in any weather and lighting conditions, including cluttered, challenging environments, to achieve optimal detection for all types of threats. Magos' MAS software seamlessly integrates with major camera manufacturers, video management systems, and access control systems, ensuring a quick and easy installation with no site-specific customization.
And an example how it looks.
Here's how the MAS AI solution operates. The radar detects and tracks the targets. The cameras are automatically and continuously cued to the targets. Magos' video-based AI algorithm classifies the targets as human, animal, or vehicle, while filtering out false alarms caused by wildlife. When a relevant threat is detected, an alarm is triggered and generates an event on the video management system, providing the operator with only relevant information for reaction.
And this video that you see right now is available under YouTube in our Magos channel as well. Here a little remark, a blue zone is our default color for an alarm zone, and you see we have movement already inside of the alarm zone. This is by an animal, so therefore this categorized as animal object does not trigger alarm, and this
our MAS AI solution ensures a fully autonomous and efficient perimeter protection.
The moment it hits the alarm zone, an alarm is triggered because of human movement is not filtered in our alarm zone. In other words, it's supposed to trigger alarm. This is the major functionality
for your site, AI, reducing nuisance alarms to near zero without compromising threat detection. Magos' cost-effective perimeter security system provides a reliable, field-proven solution to your security needs. With extensive experience in over 40 countries and dozens of verticals, Magos is a world-leading expert in perimeter security. Magos. Better security, more coverage, less investment.
So sorry to show you a video, but it's just impossible to explain what we do in a shorter way. So therefore this video is really helpful. You're invited to use it in your presentations. Summary, therefore, about this solution. As we said, there is the radar that is able to track multi-targets, several targets all across the coverage area. It is a solution that where basically the advantages of the radar are completing a solution as to the fact that cameras is the best possible technology to display events to the human eye, so therefore for the human easiest to process. However, under special conditions or under not so special, under usual conditions like low light conditions or bad weather conditions, the impact on optical solutions is relatively high. If you add radars to the game, this is very robust if it comes to those type of weather conditions, and therefore that's the ideal combination. It would make sense, or it would make much less sense to combine optical systems with another optical system, and therefore basically face the same difficulties during the same, let's say, fog or snowfall conditions. Altogether, the cost effectiveness is given at a minimum perimeter size. I would say less than about 400 or 500 meters is probably very small for us. But on the other hand, a perimeter line of several hundreds of meters is not necessarily a large plot or perimeter. One sec. Okay, understood. Thanks for the hint. I just repeat my comments on that little video scene there. On the one hand, you saw. Let's go back there.
For all or vehicle, while when a video management system sends information for reaction.
Here I try to highlight that we have already an animal detected inside of an alarm zone. It does not trigger alarm if the settings is done like this. Only once a person, and in this case person or humans would not be filtered, only if a person hits the alarm zone, then alarm goes off. The main purpose of our mass AI is the ability to therefore filter wildlife movement and hence reduce the information to the relevant. We come to this in 1 second. Um, that's the key remark, I guess. Back to that summary. Minimum sizes, but that's not really huge parameters. So therefore, once you can um, on the one end, serve a site with above 500 meters. On the other hand, ideally, even save a pole, including the groundwork and the cabling, to be considered. This is where you definitely can save money by the integration, simply because of the wide range of the radar and the fact that we can integrate with existing cameras as well and so forth. So it's not necessary, it's not required that the camera is installed at the same point like the radar. We can integrate with other cameras and we can use those as long as they're IP-PTZs following a minimum standard. And second, obviously, we can or we will auto track only in those areas where the targets are inside of the coverage areas of the radars. Same thing applies. You can combine several radars with several cameras. If you work with Magos, there is literally no limit. All type of zones and priorities can be set, and others. Um, Key of the solution itself is not first of all saving costs. Key is to filter what otherwise is a lot of data, but data not processed, although we as end customers invest a lot of money in the security concept and security guarding services. If I generate too much data but no information, it doesn't really help. What I mean? If we protect a site with, say, 100 video channels, the chances that we will be able to watch every single video with basically no event happening, because the camera looks at another locked door or in front of a window where nothing happens, in front of your driveway and no vehicle is passing, it's impossible to pay attention, let's say. Versus if we reduce the information, first of all, by the radar as a movement sensor, if you want, we show or we could set up the system in a way that it shows the video only once movement is detected. So therefore, this is very, very important to understand the filtering function of such integrated solution. Second, if you choose so, slash if it's relevant, and in many installations that we do, animal traffic is relevant because it's not sites necessarily that they are downtown, it's outside of the urban areas, so therefore you have forests nearby and whatnot, so therefore you have a lot of animal traffic during the night. That's not false alarms strictly, it's nuisance alarms, but in most of the cases animal movement is not seen as a threat. Therefore, if relevant for you, add AI to the solution as displayed earlier, and like this, filter animals from triggering alarms. Again, the whole effect is you filter the information down to the relevant, and therefore our security guards are able to focus on the right events. Ideally, we can therefore prevent an unwanted event from happening, and this is, let's say, nothing you can guarantee, as you don't know, you can't forecast the behavior of a potential intruder. However, we have a much bigger chance. So therefore, post-event technology, CCTV, you look at video files once something happened, something got stolen, or whatever is the case, change it into a pre-event solution, or at least pre-event capability, as to the fact that we have wide coverage, we can pre-alarm earlier, we have a focused information for the security guard, so therefore the execution of the security processes is more precise and triggered earlier, and therefore ideally we can prevent an unwanted event to happen. This is what we are all after. A scenario as example: a person approaches the site, the the radar triggers, the security guard opens light or uses audio. The potential intruder understands he's already looked at, and therefore he turns around and walks away. Um, Some details about the radars itself. We look at the ranges, but as indicated here, for human, we talk about from 150 to 800 meters across the different models. Larger items will be detected in a longer distance. Depends on the size of the item, of the vehicle or boat. It could be 1200 meters or even more. Um, these numbers are relatively conservative, but at the end of the day, one of the difficulties, let's say, with regards to radar technology as such, it is very site specific how exactly the performance will look like. So therefore, it's impossible to tell you a specific radar will detect exactly 600 meters and not more. Reality is that it will be always in a range. We have relatively wide coverage and as well high vertical opening angles. That is a benefit of a Magos radar compared to other solutions in the market, especially compared to 360-degree radars in that price range. If they come with a very narrow vertical angle, it means that you have large blind spots, and potentially after receiving an alarm, the object already passed the detection area, and therefore there is nothing that can be auto-tracked. This is the advantage of using Magos radars up to 7 meters, give or take. We have no blind spot, plus with a wide vertical angle, we can, let's say, we have a good chance to track a person even across natural or built elevations, walking up, walking down. If the radar is high enough, the chances that you keep on tracking an item is relatively high. I mentioned earlier, and I won't read this slide to you, I mentioned earlier that the integration is absolutely key, and you saw in that little video already examples of the auto tracking of a PTC. So integration you saw as well, a snapshot. If you have questions about that, contact us and let us check if the models are available, if the software is we are integrated with already, and if not, we will find means to ensure that we can use with the components that are already part of your solution. We saw the distances as we indicated. There are different models, therefore shortest range 150 meters, longest give or take 1000. And we'll wait. I will showcase the AI in a little bit. Examples of integrations here. This one I was looking for. I want to highlight what is typical vertical markets. So therefore, dear end customers, if you're working in these fields, we believe that we could fit quite well. slash dear integrators if you serve such clients. Besides the first group of verticals, which is military forces, police, and so forth, I believe the right now most interesting group of verticals can be summarized as critical infrastructure. And critical infrastructure uh, we can group in on the one hand anything that is uh, energy based, so therefore electric power generation of any kind, uh, the networks, so power transmission related to that, and obviously including alternative energies. The solar field, photovoltaic, is a very, very active vertical for us at that moment in Europe. So including photovoltaic, all the energy-related topics are a part of critical infrastructure that we absolutely focus on at that moment. Second is basically traffic-related, airports, seaports, as well railway is another group of critical infrastructure that we do protect. As I mentioned, seaports, anything next to water surface, and therefore that could be chemical industry as example as well, and those type of production sites. Anything next to water surface is potentially a good client for radar technology, simply because during the seasons or during the times of the day, there is circumstances where, as example, because of fog, the optical systems like cameras do have a lot of problems. Such weather conditions, however, as we said, do not have any impact on the performance of the radars. So therefore, the combination makes a lot of sense if you have your production site next to a river and you have a little, sorry, and you have a seaport at the riverside. Then those areas ideally can be monitored with radars, as water surface is actually even better or easier to handle than necessarily the on land installations. It's to do with the clutter that we receive back from the surface. Still in the area of critical infrastructure, we could summarize others, like on the one hand, oil and gas storage as example. On the other hand, water facilities. You could add data centers to the same topic. So all those areas are part of where we work. And the last group of verticals is basically pretty much everything else, as indicated, production sites, but as well logistics sites, warehouses. All those sites can be protected with radars, and uh, the only indication that would uh, be helpful for you to remember is, on the one hand, the radar needs line of sight contact to the object. If a radar would be blocked by other objects, then it's not the ideal situation, simply because it's not an X-ray. So therefore, we need line of sight. And the other point is that we want to have a certain size of open land where the movement can be tracked, and that's to do with the filtering basically. If we trigger an alarm on a single detection, then every branch of a tree being moved by the wind would trigger alarm. That would be a lot of false alarms. Therefore, we need a minimum distance of a few meters where we can ensure that the filter mechanisms do work, and differentiation between, as I said, wind-based or maybe a little, yeah, leaves and stuff like that can be filtered versus a walking person or similar will be declared as target and monitored. Um, As I'm saying, obviously, person and vehicles are the most important objects that we auto track. There is another consideration and that is we suggest to use radars only once there is a situation where you would say the expectation is only a few movements, a few moving objects over time. If you have a very busy street, if you have a very busy stadium situation, to indicate that there's movement would not be a lot of help. So therefore, it's not a people count or station monitoring device to indicate behavior of people. This is not where radars play. We detect movement. We position the camera to auto track the object, and therefore we show there is movement, and it's up to the security guard to verify if it's a threat or not and whether or not to trigger processes. This is basically where we work, where we are home. I was speaking about um, the categorization uh, of objects, and let me think. I start with this one. I want to show you. I want to show you an example. How or what to expect, how does it look like, and what's the
To show
difference
you something.
between the
Here we go.
categorization
We
possibilities.
will
So
have two targets on display.
here, one target already disappeared. Here you have an example of those typical webinars, live demonstrations that I do on those Fridays. Um, Here, as example, you have two live targets in this case. And without any analytics, that's the way those targets are highlighted. You see there is a setup on a path in a forest, and the radar position is over here. That's the range of the radar indicated, and the camera is at the same spot. And therefore, you would have two targets on display, and with no analytics, obviously, there is no indication what type of movement is monitored. And I show you exactly the same two targets again after I enable what we call radar-based analytics slash
Like to
it's
start
basically
with
speed-based.
the radar-based classification, which is the new.
Um, Dragging forward a little bit. Here we go.
If
As we
I
said,
display the same two targets, both apparently.
the radar-based classification is not a reliable analytics based on the frequency shift to differentiate different object types. You can differentiate different targets, but it's just not reliable to say this is um, a person versus this is a large animal. That will not be possible, and hence the indication here is this is a speed-based parameter. There's a threshold, and those two targets are above the threshold, so therefore both targets are shown as vehicle, and slow targets would be shown as person. This is not what we call analytics. This is a gimmick, if you want. A customer asked us to provide this information in that way, and therefore that's part of the settings that you can choose. But you will see the difference now to the video-based classification. Same situation again. Fast forwarding here, I add Mars AI, and as we say, Mars AI uh, is a software, is an application that uses the video stream. You define the cameras that are enabled or included, and then we use exactly the same scene
Again,
again.
that's a recording where I did use Mars AI. So therefore, let's see what happens. And we will see the same two targets coming up.
And here you see those two targets that have been classified by speed as vehicles come up now as a bicycle and a person. And the only reason why this is shown as vehicles earlier is that this guy was it's a jogger, a running person. This is a bicycle that was fast enough, and therefore they were classified as vehicles. Only if we use the video stream, then we are able to categorize correctly, and therefore you can see person and bicycle.
One
This is
is
what you get
a
of analytics once you
uh,
use the video
two-wheeler
stream analytics
motorcycle. The other
of
one is
Magos.
a
And
person.
the
As a matter of fact, this
beauty
was
of
a jogger, so
such
therefore it is a
solution is
person
that
that
wherever
was
those targets
relatively
appear,
quick.
the
So only with the
classification of
Mass
those
AI
targets
using the video,
happens
you get the
almost
proper
real time, and therefore
classification.
there's no delay.
Same here.
We
It is
have
actually not a
such
motorcycle.
analytics across the whole detection range, um, and you know, the intruder, the object might appear anywhere, and therefore we need this dynamic analytics anywhere as well to fit the solution or to fit the strength of the radar, that we are not analyzing only, let's say, on a little parking lot. No, we do analyze wherever it happens. This is one example. The the other video I would like to show here is from another webinar that I've done, and here again you see a very specific scene. Don't wonder why I put a camera and the radar basically on the zero line of the elevation here. The general idea of this exercise was that most of you or some of you might know that the radar is, or the radars that we offer is two-dimensional information radars. Means we have the X and Y, but means the position of the object, but we don't have the elevation. And here's an example of setting up um, with people walking across a bridge here. You see the bridge, and then a moment later they will disappear. They disappear, and the camera would point at a position that is not very telling about is it a colleague or is it an unknown person. Uh, this is a part of the two-dimensional information. If you use Magos, you have the capability to use settings for a camera, so therefore the camera will automatically at a specific at a specific position point to the relevant bit of that image slash will elevate the camera uh, to the relevant point, and hence without manual interference, wherever we have or whenever we have a detection at this point by the radar, the camera will automatically show you relevant information rather than the security guard needs to do anything manually. That's the one part of this session I did quite some time ago. And the second part, you see the vehicles driving there. You see a bunch of targets, or by now dead targets, as we call it, in that video. And later on, here's a live target again. Later on, I show the change if I add Mass AI. Sorry, I jumped a bit quickly here. Adding Mass AI to exactly this scenario, you can already see you have a categorized item, and as well those that are not moving are categorized already in the video stream instantly. However, they are not shown in mass simply because they were not moving. Um, you need very well calibrated cameras or video streams to have a maximum result of the video analytic. function, and therefore that's the last piece that's illustrated here. Press play, use good zoom levels or short field of view, and therefore you can see immediately by doing the right settings. Let's say we have 1, 2, 3, 4 vehicles moving at that moment, categorized as vehicles, and that's exactly the strength of the solution. Once set up well, multi-targets can be categorized, and you will have this additional information for the guard and the filtering function once it's animals. This is just an illustration from very basic material, so to speak, as this is videos I took from the webinars, but that's to me a good way to illustrate the strength of the solutions. And again, who's interested, that's exactly those little topics and demos and so forth that I try to cover during the webinars on the first Friday of the month. What is important to know with regards to preparations of sites and so forth, especially for those colleagues that are not too familiar with radars yet, it's very important to do a proper site survey. I just returned from a site yesterday in Italy where on the map things look relatively simple. Let me just see. I show you this as an example here. Let's zoom in a bit further. No matter what that is, and that's not the site I was visiting yesterday. If you plan a radar and you use the coverage only, it looks like great. Here I put a radar. This is my coverage, in this case 150 meters, and everything will be monitored. That will not be the case because depending on the height of those objects here, those will block, of course, as well, depending on the mounting elevation of the radar itself. Second, it looks like we can cover all this, but indicated here, if you have a wall blocking the radar, then let me illustrate. Looking at the line of sight of the radar, you could see that here there is a shadow, so to speak, or a blind spot, and that's to do with the height of that wall and in accordance the higher elevation of that radar. So therefore, in this case, the shadow is not even very big. But ignoring those type of things would mean that you plan coverage and you will find out, oh, sorry, no, you see, this is cut out all that way. So therefore, the shadow is much wider. This is the shadow of the satellite image. So therefore, those type of things need to be considered, and we might say, well, would I have a better coverage if I put the radar somewhere else, and those type of things. Some areas or sometimes we have like basically one building and a four corners, four radars design, then this is most likely a site that is relatively simple. Others are much more sophisticated and absolutely important to look at those. So therefore, do a proper site survey and share this the images with us if you're allowed to, or let's say higher effort, we can provide such service as well and do a site survey together. Key is have a very good plan about where to put a radar and what will it cover. Once, especially a pole is set in the ground, it will be very difficult to move it, and therefore it would be unfortunate if the pole is not in a very good position. It happened to us as well that between the planning phase of a project and the realization, easily a year and a half can pass, and suddenly things look totally different because the end customer did add a part of a building or whatnot, and therefore the position of the radar looked good 1.5 years ago, and now with an object in front of the radar, the position doesn't make sense anymore. Those type of things need to be considered because ultimately, if you give a plan to a subcontractor who is responsible to mount the pole, they will put the pole exactly in the position on the plan. It's not their business to decide whether or not the field of view of any sensor you put on the pole is still given or not. So in those cases, monitor this exactly, and or ask them to show via video or whatnot uh, what is the view of that position at that given moment. Again, that applies mainly for examples where a site has been planned, and the time up until realization is several months or more. This is how a design and the design tool looks like. So therefore, that's what we play with, let's say, to consider whether or not a radar is placed ideally in this position, or what's the difference if we can put it somewhere else. This is the tools that we do work with, and our integrators as well. And very, very similar, the user interface of the live software, the mass software of Magos. You can define different radars, you can add cameras, um, you can create different areas for pre-alarm and alarm, and as well you can use settings during the day versus during weekend or during the night, and swap between those automatically by calendar or by an input from the guard. So therefore, all sorts of scenarios are possible using this user interface. Summary, looking at those components, Magos offers the right user interface to do both design, but as well the final system at that client based on map information. As you saw, we can add drawings if necessary, and indicate buildings that are not yet available on the satellite images of the typical providers. Therefore, you have the right map information, and you had an illustration of how it looks like, where to position the sensors and whatnot. Most important, you see the targets live or recorded here in this example, recorded to illustrate what direction did an object take, and you saw that cameras do auto follow those, and the analytics capabilities. This is the strength of the Magos integrated solution, not missing a target, being able to auto follow without manual interference by the guard, and the focused information to be able to trigger the right process earlier than probably without such integrated solution, and therefore based on pre-alarm information and based on very precise information. So therefore the focus of the guard is on the right object rather than being disrupted and looking at scenarios that are not a threat and missing the real one. This is the strength of the solution. We talked about the robustness with regards to light conditions, weather conditions, and whatnot. As well, radars, once calibrated correctly, are relatively robust with regards to false alarms versus, let's say, sensors that might be smart fences and those type of things. Very difficult to differentiate whether there is leaves or dust or whatnot flying with the wind, and therefore you might have a high number of false alarms. If we have a high number of false alarms, then it's just human to not react, let's say, and therefore miss an alarm that is actually relevant. So very, very low false alarm rates is the final combination of the value, so to speak, of such integrated solution. and therefore, hopefully, we are able to uh, to focus your personal stuff, your security stuff on the right events, and to make the end customer's security system higher performing. This is what Magos does. I hope this was a good overview. I would love to hear whether you think your challenge security wise is something where Radar could help. Please contact us at eric at magoses.com or see us via our website. Let us know where we can help, and we will help to design the right system. And we do have the right integrators in your area to help to solve such a challenge. Therefore, looking forward to hearing where we can assist. And next time, next first Friday of November, it will be then. I will again focus on specific topics, how to address them, and how to do the settings in Mars, slash usually news about releases of our software and the new features that we bring to the table. That's the typical content of the Friday webinars. I'm looking forward to having you on board for the next one. Have a great weekend ahead. Thanks for your attention, thanks for your time, and thanks for your interest in Magos. Oh,